Hello guys, a very happy good evening to all of you. And guys, now we are just going to see the next thing that is so much related to which one? Pure substance. Okay. So in the previous chapter we just completed a lot of good things. It means a lot of other things, especially in the 10th question we have just completed. So without wasting time, let us get started. Okay. So okay. So what is the first one? So you can see this one. For a single compound system, vapor and coexist in a mechanical, thermal and phase equilibrium. So during that time, what will be means definitely the Gibbs free energy will be same. Okay. So Gibbs it means Gibbs free energy for gas equal to Gibbs free energy of liquid. Okay, of fluid. Okay, equality it means liquidity of a specific Gibbs free energy will be everything will be equal. Okay, you can see subscript G it means on liquid everything will be same. Okay, so you need to understand. So you can see this one, this and this question is literally same. Okay, I think so got this point. So what is the thing? Vapor phase will be equal to the liquid phase. Okay, that's it. Okay, you can say gas phase equal to liquid phase. Okay, we can just see the next question. So what they have given in the steady phase, superheated steam pressure. Okay, throttling process. So H1 equal to H2. Okay, so you can see 450. Oh no. Okay, it's throttled. Okay, no. This is not throttling. Okay, 230 bar and insulated. You can see everything is at the rate of 2 kg per second. So m dot is 2 kg per second. The change in kinetic energy and potential energy is 0. Okay, the rate of entropy generation down rate of D I think rate of entropy generation of this one during the throttling process. Rate of entropy generation is generally how much rate of ds divided by dt will be there. So what is the thing? Okay, so each and everything H and S is given. So entropy is, what is the formula of entropy? Entropy is, it means ds divided by d theta. Okay, this is change of entropy. Okay, so let us see. Okay, just 1 second. Wait. So rate of entropy generation during the throttling process. Okay. Okay. See, temperature is temperature is constant. Which check. So answer is 12. You can see this one. So I can see the pressure 1 and pressure 2 is everything given, temperature 1 and temperature 2, and m dot and each and everything is given. So this is the entire thing. Okay, so generally as it's been insulated and each and everything is been there, so they are asking me, it means they are asking to find the, it means rate of entropy generation. Okay, so what is the rate of entropy change? You can see this one. Okay, change of entropy equal to, it means change of entropy equal to d, it means delta q divided by t with respect to entropy generation. Okay, so first we need to calculate the entropy. Okay, this is the basic thing that you just want to calculate. Okay, so after calculating the entropy only we can just calculate each and everything. Okay, so you can see by the formula of interpolation. Okay, you can see how the interpolation is being brought out. You can see this one. Okay, so basically here they have just given the entropy formula. Okay, okay, so this is a basic thing. So it means with relation to, it means H1 and H2, you can see since it's been throttling process, yes, I just told correct, H2 equal to H1. Okay, so by interpolation you can just calculate the S. Okay, it means change of which one entropy. So in this side we need to plot, in one side we need to plot the enthalpy, another side we need to plot entropy. Okay, just a simple thing. Okay, so you can see this one. So they have just given thermodynamic property of superheated steam 70 bar and 450. So what will be the thing? So since it is the temperature is between 450 degrees Celsius to which one? 400 degrees Celsius. Okay, I think you are getting the point. So you can see this one. So at 70 bar they have just given this one. So it means you need to input this kind of 328.3 minus of which one? So you can see this first one 400. So 3231.7 so divided by 3344.9, this one minus of 3231.7 something. So S2 minus of S1. So S1 is what? This one 6.92. Okay, next one 7.08 minus of this one 6.92. So while we are just making S2 will become which certain value as 7.0045. This value will come in the S2. So the next thing can be delta is equal to delta Q divided by T plus of entropy generation. So it means this Q, this anything will be there since it is insulator. Okay, so S2 minus of S1 equal to entropy generation into m dot. Okay, so what is the S2? It is this value, and what is the S1? This value. Okay, 6 point. So 7.00 something minus of 6.6353 something into m dot. Okay, m dot is how much? 2 kg. Just multiply and we'll get the record answer of entropy generation. Okay, basic thing only guys. No need to just confuse ourselves. Okay. I think so you are getting the point. Okay, so okay, so next we will be seeing now, it means especially we have seen this one question. Okay, so now we will just see the open system analysis. Okay, it means as I just covered the entire thing, so now we will be seeing the open system. Okay, so after completing that we can just go to the entropy and as well as the second law, each and everything we will just see upon. Okay, okay, so this thing, okay, you can see open system analysis. Okay, I think so we can complete this quite sooner. Okay, so we can see the first question. Okay, so what is the first question? You can see mass flow rate m dot. Okay, and test diffuser. Okay, diffuser is this one. Okay, so it means pressure 1, temperature 1, velocity. Okay, exit area. Okay, q dot, the pressure is diffuser, so it is asking the pressure 2. Okay, so what will be the pressure 2? Okay, so characteristic on each and everything is given. So what is the formula for this one? Since it is an open system analysis, so what could be the formula? So since you can see q dot equal to means in internal energy plus of work done. Okay, so here the syndicate of work done is there? No. So here definitely there is no work done, so the work done will be entirely 0. Okay, so what could be the formula? So I will just show it to you. You can see this one. So this is the entire formula has been related here. Okay, so this is the diffuser. So you can see here potential kinetic energy and enthalpy. Okay, q dot equal to change of kinetic energy plus change of potential energy plus change of enthalpy. Okay, this is the entire thing we need to just put upon. Okay, so we can see heat loss is being there, so it is minus 8 into 10 power 3 joule per second. So change of kinetic energy is, you can see 200. So then we have also need to calculate the velocity also. Okay, so v1 we just know v1 is 200 meter per second, so v2 we don't know. Okay, and area they have just given. Okay, so mass flow rate is 2 kg. Okay, mass flow rate will be same. Okay, rho1 a1 of c1 equal to rho2 a2 of c2. Okay, so you can see based upon this we can b1 equal to mrt. Okay, or P1 equal to rho 1 of RT. Okay, so you can see P1 is 100 into 10 power 3 Pascal divided by R is gas constant. You can see 287 joule per okay into degree Celsius is 273 plus 30 301, so 303. Okay, you can see this is density 1. Okay, by calculating this density 1 we can just go on and input here. Okay, it means density 1 we know, area 1 we don't know. Okay, density C1 we know, but you can see, or we can just go with this one. Okay, continuation A1 V1 equal to A2 of V2. Okay, so but for this also see how much checkpoint is there just given. Okay, so so you see m dot equal to rho 1 A1 of C1. Okay, so we can see by this we can calculate the A1. Okay, so density 1 A1 C1 we just know. Okay, so rho 1 A1 C1, so the m dot is how much? 2 kg per second. Okay, so equal to rho 2 A2 of C2. Okay, so by here also we can just put m dot equal to rho 2 A2 of C2. So exit temperature is given. Okay, area 2 is given, so area 2 is given, but C2 we don't know, and also density 2 also we don't know. So how we can calculate? A1 V1 equal to A2 of V2. Okay, This is continued equation. So A1 V1 we know, A2 we know, okay, 200 400 given. So by this we can calculate the V2. So by this one we can calculate the density too, okay. Wow, see how much a bigger thing has been there, okay. So it means this entire thing is in layout 2 is C2 square minus of C1 square divided by 2. So whether they have just given any kind of kinetic and potential energy, no, potential energy is entirely 0. So next one is enthalpy, okay. So guys, wait. So equal to P2 V2 equal to mR of T2, okay. So you can see T2 we know, and it means P2 there also P2 equal to mR T2 divided by velocity 2. It is wait. It is volume, okay. Sorry. So okay. Density equal to mass by volume. So you can see since density 2 P2 equal to density 2 of R into T2. So calculate the density 2, we can calculate each and everything, okay. So you can see this one, okay. See how much thing it's been so much complicated, okay. So you can see this one P naught equal to rho naught of R of T naught, okay. M dot equal to rho naught A naught of C naught, okay. So since P naught is this one, okay, it means you just correlate, that's it, okay. So it means P naught equal to M dot A naught of C naught, okay, just put here, and we know the C naught, okay. It means C1 we know, okay. I think so you can understand, guys, just a simple equation only, okay. So by this you can just calculate each and everything, okay. Suppose you can see why they have just given it the same, because you can see so based upon this equation you can see C2 square minus of C1 square divided by 2 plus of potential energy eventually 0 plus of kinetic energy. So kinetic energy means enthalpy. So enthalpy you can see this thing, okay, 2 into 1000 of 15, okay. Why? How it has been given 15? Just think. So enthalpy is what? Enthalpy is just think, it is just a temperature difference, okay. So suppose I need to give an example. There is a one diffuser problem. Where is diffuser? This is not right. So you can see diffuser, this is only the diffuser. So what will be the thing for enthalpy? It is entirely depend on the temperature change. So T2 minus of T1. So whenever they just given, you can see it is completely T2, it means 30 minus of 45 degrees Celsius, okay, that's it, okay. So and the specific, just a simple thing, guys, it means change of enthalpy is what? Cp of delta T, okay. Just put here and calculate the equation, and based upon this we will get the C2 value here, okay. After calculating C2 value, we will just go and put here and we can calculate the entire thing, okay. See guys, at the beginning it will be a little bit complicated, but as you just go, it will be so much easier to you, okay. So you can just see the next problem. Next thing you can see carbon dioxide centers adiabatic rigid nozzle, okay. Sorry, nozzle is like this, okay. Q equal to 0, okay. Pressure 1 P1 1 megapascal, T1 equal to 500 degrees Celsius. Mass flow rate m dot is 1.5 kg per second. So inlet area 40 centimeter square. Exit is exit velocity. V2 is 10 times of V1, okay. Ideal gas, CO2 is ideal gas, okay. So gas constant, okay. Ratio specific, so exit temperature T2 they are asking. So what will be the T2? So since you can see T1 P1 1 minus of gamma by gamma equal to T2 P2 1 minus of gamma by gamma, okay. So what is the ratio of gamma? Gamma is 1.29, okay. So T1 P1 we know, but T2 P2 we don't know, okay. So how we can just calculate this one, okay. For example, since it is ideal gas, P1 equal to rho 1 R of T1, okay. Suppose m dot is given, m dot is it means m dot is rho 1 A1 of CV1 equal to rho 2 A2 of C2, or m dot equal to rho rho 2 A2 of C2. Okay, so since we don't know the area 2, okay, yeah, wait, inlet area. Okay, so just think it, guys, how we can just calculate. It means P2 is so simple, rho 2 R of T2. Okay, since they are asking the temperature, and so we need to calculate the pressure. So let us suppose like this, we can just Q dot equal to W plus of change of kinetic energy plus change of potential energy plus change of enthalpy. So definitely here what will be 0? So the Q will be 0 as well as the potential energy will be 0. Okay, work done also will be 0. So kinetic energy equal to plus of change of enthalpy equal to 0. So C2 square minus of C1 square divided by 2 plus of Cp Cp T2 minus of T1 equal to 0. Okay. Based upon this also we can't calculate the T2. Okay, this is one formula. Okay, so next it means this is one formula, and this is, see guys, in this thing entirely every problem will be so much bigger on. Okay, so P2 equal to rho naught R of T2. Okay, so definitely this, by this we can calculate. Just think guys, how we can just calculate the each and everything. Some key point we are missing. Okay, just a smaller key point. Okay. So guys, so for example you can see m dot is what, rho 1 A1 of C1. Okay, so P1 equal to rho 1 R of T1. Okay, by this we can calculate P1 equal to certain value. Okay, P1 given 1 megapascal, R we know T1 into, just calculate the density 1. So m dot equal to rho 1 we can put here, and A1 C1. So by this we can calculate the velocity of C1. Okay, so what is the velocity of C2? C2 equal to 10 times of C1. Okay, so m dot equal to which one? This 2, rho 2 A2 of C2. Okay, so what is the pressure to P2 equal to rho 2 R of T2. Okay, so literally we do have two formulas. Okay, so you can see after calculating, you can see C1 we just got, and based upon this put here C2 we also got. Okay, so C2 and C1 we just got. Okay, Cp, this one T2 minus of T1. So T1 we know, and based upon this you can calculate the T2. Okay, wow, such a simple question. I think so you can understand. So just a basic sense. So next you can just go for this third question. So you can see a steam flows through a nozzle at mass flow rate. Okay, heat loss. Okay, enthalpy at inlet and exit. Okay, assuming C1 0. So they are asking the C2. What will be the C2? Okay, since it is nozzle, so change of kinetic energy plus of change of enthalpy equal to Q dot. Okay, Q dot is minus. Okay, so kinetic energy C2 square minus of C1 square by 2 plus of enthalpy is H2 minus of H1 equal to minus of 5 into 10 power 3 joules per second. Okay, it means what? So multiply each and everything with respect to which one? 0.1 kg per second. Okay, 0.1 kg per second. So here also 0.1 kg per second. Okay, okay, so now we multiply, and we, by this we can, the C1 is entirely 0, by this we can calculate the C2. Okay, so you can see m dot need to be equal to m dot. Okay, entire thing. So much simple, you can easily calculate and you can find the answer. Okay, that's it. So you can just go for the next condition. The fourth question that has been given, the theoretical maximum velocity of theoretical maximum velocity V equal to root of gamma of RT. Okay, so gamma specificate is in Cp equal to gamma r minus. Okay, so what could be the thing? So little bit related to this, since temperature is given, so you can see, okay, this is other formula. Okay, C equal to root of 2 Cp of T, T absolute. Okay, so you can see what is the thing, 2 into 1005 into 700. This is C. So you can calculate easily, that's it. Okay, we can just go for the fifth question. So you can see superheated steam at 2 bars and 300 Kelvin with enthalpy. Okay, enters horizontal adiabatic nozzle. Okay, negligible velocity. Okay, P1 given, P2 given, and enthalpy also given, H1 given, H2 is given. So temperature T1 is given. Okay, they are asking the exit velocity. So V2 is how much? So generally it means adiabatic, C2 minus of C1 square divided by 2 plus of Cp T2 minus of T1. Okay, equal to this one, or H2 minus of H1. So we need to calculate the C1. Okay, m dot method given. Okay, then m dot they have been given, so m dot is 1 kg. Okay, so P1 equal to rho 1 r of T1. Since m dot is same, rho 1 A1 of T1 of V1 equal to rho 2 A2 of T2 of V2, sorry. So pressure is given. So you can see this entire thing, they have given negligible velocity. So C1 is 0. So now we can calculate the C2 directly. Okay. That's it. Okay, I think so I got the point. So since it is been given in kilojoule, we need just only the joules. Okay, that's it. So you can see the next question. Steam at initial enthalpy. Okay, initial and inlet velocity enters inside nozzle. V1, V2 equal to V2 is how much? So V1 is given 100 meter per second, H1 is given 100 kilojoule per kg. Exit enthalpy H2 they are asking. Okay, simple thing only. You can see it is given. Okay, kilojoule per kg, simple. C2 square minus of C1 square divided by 2 plus of H2 minus of H1. Okay, this one is given 200 meter per second. So based upon this you can calculate and definitely that's it. Okay, that's it. So we can just go to the seventh question. So an equimolar mixture of two ideal gases. Okay, so seventh question is equimolar mixture of two ideal gases. Two ideal gases is that A and B expands isotropically in a gases. Get this nozzle. Okay, nozzle is this one. P1 given, T1 given, P2 given, T2 they are asking. Okay, simple thing. It means what is the formula? T1 P1 1 minus of gamma by gamma equal to T2 P2 1 minus of gamma by gamma. That's it. So you can see molar mass and Cp is given. So we need to calculate the gamma. Okay. So how we can calculate the gamma? So gamma is Cp divided by Cv or Cp minus of Cv equal to R. Okay, so this also we can calculate. So Cp equal to gamma of r minus of wait gamma r and r of gamma will be gamma minus 1. Okay, that's it. Gamma minus 1. Okay, cv is r of gamma minus 1. Okay. So we need to find the common cp and common r. Okay, so how we can just calculate r? So r equal to universal gas constant by a molecular mixture. Okay, so you can see this one. So m of mixture equal to 1 divided by x1 of m1 plus x2 of m2. So x1 and x2 are mass fraction. Okay, wait I'm just writing this formula in a different way. See, this is the most important thing, guys, because you can see how much time I'm just turning. Suppose if you don't revise properly, the same kind of thing you will also do. Okay, m of k we just wrote it correct. Okay, m of mixture of n of mixture. Okay, n we don't know. Okay, just you can see I think so. He just calculated it simply. Okay, see guys, this is a simple thing. So to calculate this simple thing, how much bigger process is being given in the top above process. Okay, so I think so you understood. Okay, just which you can see cp of picture, how we can just calculate. So m1 of cp1 plus m2 of cp2 equal to m1 plus of m2 of cp of mixture. Okay, m1 m2 cp1 cp2 and this one and we based upon this cp2 we will just calculate. Okay, so after calculating cp1 and cp2 each and everything we just know, come to a common thing. Okay, you can see what is the m of mixture. M of mixture equal to x1 bar of m1 plus x2 bar of m2. Okay, so it means you can see the molar fraction has been added and the x1 and x2 1 1 1 and you can see divided by 2. Okay, just a divided by 2, that's it. Okay, well you calculate a molecular mixture, I think so you got the point. So after calculating the molecular mixture, okay, so cp of mixture divided by 2 is 20 cp of mixture so it means how to say, means just a simple thing guys, literally see how much time it has been taking. Okay, so cp of mixture and cp, so just multiply each and everything. Okay, simple. So while you multiply each, so you can see that just multiply this 2 and this 2, this and this 2. Okay, while you are multiplying cp of a will be 29.13 and Cp of B will be 28.65. so mixture means just make sure it is been, it means take an average only. So 29.13 plus of 28.65 divided by 2, so we are taking 28.89 will be, this is Cp of mixture. Okay, so Cp of mixture is this one, so Cv is Cp minus of R. Okay, so R bar. Okay, so Cv equal to, this one is 28.89 minus of 8.314, Cv we get 20, so gamma equal to Cp divided by Cv, so 28 point something divided by 20, so we will calculate 1.4 and 0.4 something will come. Okay, then T2 by T1 equal to P2 by P1, 1 by gamma, put here and calculate that, that's it. Okay, so I think so you are getting the point. Simple question, but you can see how much complicated it is. Okay, so we can just go to the next question, this one. Okay, you can see an ideal gas expands in an adiabatic frictionless nozzle with the inlet condition. Okay, they are asking velocity of the gases, so adiabatic nozzle is this one. Okay, so pressure 1, temperature 1 and ambient. Okay, P2 given, so T2 we don't know. Okay, so they are asking us to calculate the C2. Okay, so neglecting inlet kinetic energy. Okay, so C2 square minus of C1 square, okay, divided by 2 minus of, sorry, plus of Cp T2 minus of T1, okay, equal to 0. So how we can just calculate the T2? Simple. Okay, T1 P1 1 minus of gamma by gamma equal to T2 P2 1 minus of gamma by gamma. So by this we can calculate the T2. Okay, after calculating, put here and calculate the value. Okay, that's it. Okay, simple. So since it is with divided by, okay, since it is given kg, so multiply m dot, so definitely it means kg will be just m dot. Okay, m dot means just 1 kg, so according to 1 kg just multiply and put, that's it. Okay, so the next question is the pump rises. Okay, pump rises pressure of saturated liquid to, means 100 megapascal, so P2 minus of P1 is, we need to check, and work done. So okay, so it means divided by specific volume, so 2 into 10 power 3 kilopascal minus of 100 pascal, it means kilopascal. Okay, just minus, so divided by specific volume will be this one, so 1 divided by density, so it means into density will come 959 kg per meter cube. So it is given in joule, so into, it means put efficiency 0.92, so this will be the work done. Okay, so pascal will be Newton. Okay, kg, so definitely divided by kg won't come. Okay, okay, that's it, just multiply, you will get the answer. Okay, so let us see the ninth one. We are the check. So you can see, oh, I made a mistake. Okay, so since here volume will be, so volume, so how to say, m equal, it means density equal to mass by volume, so volume by density equal to 1 by of V. Okay, okay, you can see this one is specific volume, so work done of ideal equal to minus inlet of outlet specific volume of dp. Okay, so what will be the thing? Specific volume is 1 by 9, correct, so 2 into 10 power 6 minus of 100 into 10 power 3. Okay, just minus, and you can see work done of ideal is how much? Minus 1981.23. Okay, work done of actual equal to work done of ideal minus of efficiency. Okay, so 1981.2 something, there will be 0.92. Calculate and we can calculate the answer. Okay, I think so you got the point. So let us see the 10th one. Work on actual equal to ideal divided by efficiency, that's it. So next one you can see this one. So pressure temperature given, okay, pressure temperature, outlet, okay, nozzle. So pressure P1, T1 given, P2 is given, okay. So you're asking the C2. So simple T1, P1, 1 minus a comma by comma equal to T2, P2, 1 minus a comma by comma. So comma generally take 1.4 and calculate T2. So after calculating T2, C2 divided by 2 the whole square minus of Cp, T2 minus of T1 equal to 0. So Cp test and for Cp of error is so much 1.008 something, okay. Put here and calculate the C2, okay, that's it. Okay, that's it. Then okay guys, then I'll just see you in the next video. Until then, take care, bye bye, have a good day.